And we continue from the place where we stopped at. Let me improve the screen, let's say, whether it's improvement or not. I already doubt about. And we will see slides and my explanation, and time to time we will jump to this, goes into drawing. What I did right now, you see that scheme of black boxes, what is inside, we not see. But we understand that these boxes correspond, no, they create something like chain of general transformation. In our textbooks, it's called chain of general transformation applied in manufacturing, or to be completely correct, applied in mechanical engineering manufacturing, because manufacturing also may be very different, including producing of food, for instance, or including whatsoever. Manufacturing may be different. We're talking about mechanical engineering manufacturing, and in next classes we talk in more specific field already about it comes about aircraft manufacturing. Right now we're talking about mechanical engineering as a whole. And I said you that first we start with transformation of natural objects. Really, we have metal ores, we have some soil. You know that some metals, I hope you already know it, because you have maybe studied in your university, you have already studied material science. You understand that some metals, they in nature, in natural state, they looks like soil actually. In particular, it comes about aluminium alloys, fused aluminium alloys, clean, pure aluminium in nature practically does not exist, and we see it like white powder. And this white powder, after some serious chain of transformation, will be supplied to us as aluminium or aluminium alloy. So where this transformation hidden, this transformation of natural objects, and usually, once again, it comes about metallurgical processes. Metallurgical, chemical, whatsoever, what they have at the exit, how they do it. If it comes about metals, mostly we talk about metals, of course, maximum some ceramics or plastic. At the exit, they have, after these fusion processes, they have the sort of liquid. And the very first transformation after them that we may meet with, it's casting. Casting process. To remind you what it comes about, you see the beautiful picture, but you understand, must be not all things that we need are already here. Oh, here is, we see what it looks like in metallurgical manufacturing. Huge furnace, maybe not so huge furnace, it's maybe something like converter. And after this furnace, they have liquid metal or liquid plastic or liquid whatsoever. So the first group we will talk about is casting. Casting is a process. Let me to show you. Casting is a process of molten metal pouring into some shape, into some form. Such a form is called mold, usually. The process itself also, you may meet it with the name molding. Casting, molding practically means the same. So casting is a process of pouring the form of mold with liquid metal or plastic or whatsoever, some liquid, some matter in liquid state, let's say, with fuse solidification of it. and shaping, taking the shape, repeating the shape of this mold. No, of course, with some deviation in size, because you understand that hot material it's had heat expansion, and after it's solidified, after it's cooled, it's of course a bit reduced in sizes. Practically, it repeats the shape and sizes of the mold. Scheme of casting process. Right now, you see it in some different places, and let's come back to slides. First process, as I said, we meet after furnace. It will be casting process. Is it the only possible way to cast something, as you might see right now? What does it mean, casting process at all? Liquid metal taking a shape of uh, mold after solidification. Question is how to make this mold, how this mold is appeared. And due to different approaches for making mold above the wall, it's appeared a good dozen of different casting processes. Right now we will see their names. We will try to talk about their differences, but I need you to understand the most important in this classification, in this distinguishing of casting processes. It's not even the process itself. Process itself quite the same. Pour the mold with liquid metal and wait until it's solidified. Practically like this, beside of two processes like centrifugal casting and casting under pressure additionally, uh, under additional pressure. So process is quite the same. All these names, all this classification, it's appeared due to different approach of mold manufacturing, mold making. Let's see. What do you see here? Casting. Once again, look, different variants of classification, and don't be confused with it. Do remember how many engineers, so many opinions. Yeah? And let's go to the Michael Groove, and he explained some casting process here. No, as I see, nothing to add, no? Besides of, as I said you, the names of this mold casting. Так, let me do. Material. Sorry. No, not like this. Like that, maybe. Content. It has content. I do not understand why it does not show me this opportunity, this program. It has content, and it's possible to travel on. It's possible to travel by content. This book. Maybe this program has limitations. Over there. Yes. Have found casting chapter. Вот она. Metal casting processes, chapter 11 in this book. And you see right now the, at least by content of this chapter, it's possible to see some names and look at this. Something like classification there. Well, let's continue, because our point is not studying the casting really, and we may understand the primary classification, as I said, like what is the type of mold and how this mold is appeared, as I'm already said you. No, do pay attention to proposition of this author. It's categorized it as sand casting, permanent mold casting, and other expandable mold casting processes. No, in our understanding, we just have different names for different names like sand casting, plaster mold casting, the evaporating casting, the investment casting, die casting, centrifugal casting, and so on and so forth. We are not much classified in different groups. Let's go into each of them to, not practically each of them, but in some of them to understand what it comes about. What does it mean, sand casting? That is the most primitive, the most ancient way of casting, when it's really people do the shape, this mold, they make it of sand, but really it's not quite sand. It's the mixture of soil, sand, soil, and some adhesive materials, something like glue. But in the most ancient variants, of course, it was just sand, which press it into some, let it be into some box, for instance, in order to make the shape. And making the cavities in this sand, in this pressed sand, which next we mean to repeat. We may prepare this form for casting process. Of course, in the modern variants, it's not so primitive now, but technology practically is the same. First, fill some box with sand, soil, adhesive material mixture, and compress it, make a shape, like negative shape, which repeat the shape of fused product, and fill it with liquid metal. And wait. And you have casting process after this. Casting product, the casts, so call it, after this. Question is how to provide repeatability of shape. If it comes about the only part, if it comes about the part which is produced once forever, no problem. You did something like inner sculpture in this box, and next you repeat it with liquid metal. But if you'd like to repeat it sometimes, if it's manufacturing process, you do remember the technology, it's repeatability, and it's about repeatability. How to make the same cavity each time in this sand mold. For this, usually we use something like mock-up. No, not we, but those who do this, those who involved in this process. They use wooden mock-up or stone-made mock-up or whatsoever hard material which repeat completely the shape of fused product, the shape of fused part that you are going to produce. And such a mock-up, it's first it's used for shaping of the sand glue mixture, and next this mock-up is removed and you have the cavity that repeat completely this shape. To provide the better feeling, the better solidification of in this place, usually it's covered with something like additional cover, but we understand that inside, besides of liquid metal, like liquid, it may be some gases, it may be some undesirable materials, something like some wastage inside of this liquid. And at all for pouring the shape quickly and equally in all the places. It's better to think about, no, it's not better, but it's necessary to think about how it's filled. As only liquid metal or plastic or whatsoever touch this mold, mold is usually with much less temperature, some hundreds of degrees less temperature than this liquid material that you're going to pour in. It starts solidifying, and as only it's touch the mold, it's already solidified a bit, and quite clear that it's necessary to do quickly, and material should be distributed equally inside. And for this, and after, during solidification, some gases that goes out through the whole material, some, let's say, additional things unnecessary, they may float up in this material, and in order they have space where to go out actually, and because additional factors that it's rather difficult to understand, to calculate, let's say, especially in primitive manufacturing, what is the necessary volume of this liquid. No, it's not counted by drops. All the process goes very quickly, you understand. For this, additionally, in this form, in this mold, exists something like pockets, the additional channels, additional places for extra material, for removing the gases, and so on and so forth. What you see in this scheme as core, it's to the no, depending on the shape of part that you're going to produce. If you'd like to have something like a hole in this part, quite clear that you may compress this sand mixture, for instance, with your so-called mock-up, the standard of fusor part, the ideal variant of the fusor part. You may compress it, you may make a shape, but it's also necessary to repeat somehow the shape of holes, and to repeat the shape of holes clearly, normally. Usually in this mold, it's inserted so-called core, something that repeat the whole shape, and this something it's made already not of sand, of course, quite clear. Так, no, metal casting process, it's illustrated here. So first we have some material to fuse, let's say. Next, it comes about pouring material into mold. Next, removing material from mold. And when you remove material from mold, as I already said you, it will be, or do forgive me, better maybe to show this slide. It will be with additional elements. Those evacuating slots, let's say, for some here is also the process of sand mold shape making. And the additional elements in this cast which were necessary to remove extra metal, to remove gases. These additional elements, they are actually wastage. They do not belong to the part. Next, they must be removed. And here is quite clear, it's a process of removing, finishing, it's called, of ready parts. Not ready parts, actually. And after finishing, after removing these unnecessary pieces of cast, you have so-called casts. But these casts are typically not ready parts yet. They are not ready parts, and they are may be used as semi-product for the fusor machining, for instance. Some surfaces may be processed, some sizes may be changed, maybe some superficial coating may be applied. No, look, what is idea of this casting process? Actually, it comes about shaping, but we need also to think about quality. Already right now, let's start about like technologically, about what you have heard. We need to provide some quality level. What we understand now in this concept quality, how technologist, how mechanical engineer will characterize the quality. What does it mean? Quality of part be produced. No, besides of physical properties like what material it's made of, we're talking about shapes and sizes. And these shapes and sizes, they are characterized with so-called tolerances. Tolerances and deviation of sizes. It comes about the no, actually tolerance. It's about limitation of deviation of sizes. So accuracy of sizes, it's called tolerance, maybe less or more. Plus to this, so-called surface finish. Surface finish, it's a little bit more wide concept than just surface roughness, but at least surface roughness, you understand. Surface roughness, physically, it's resulted no, in metal, what we may see. Metal is polished, it's so-called high surface roughness, and metal is rather rough. Metal is not glancing. Uh, it's low surface roughness. And at least those parameters, like accuracy of sizes and shapes, and state of the surface roughness. I'm not talking already about some overburned surface or something like this. If everything is clean, but it might be resulted in different surface finish, the roughness, these peaks and valleys on the surface of metal, they may be of different values. And we need to understand that different processes, they may be resulted in different quality. In particular, look about casting. Casting is provided, it's fulfilled in hot state. What does it mean? Heat expansion. This heat expansion, of course, it's resulted what in? The part after solidifying, the cast after solidifying, it's reduced in sizes. And in case we are working with complex shapes, it's very difficult. Before appearing of computers, it was practically much difficult to calculate exactly what is the final shape, final size of this part. That is why casting usually been used for manufacturing of parts which are not of high quality in sizes and surfaces, usually, but of complex shapes. Complex shape, whatever this complex shape is, it may be repeated by casting process with very high level of repeatability, but tolerance of sizes will be not good. Accuracy, actually, not tolerance. Tolerance is our demand to accuracy. Accuracy of sizes is not good, let's say. That was for this sand casting. Once again, how sand casting is fulfilled, you see, we have some mock-up which repeat the shape of ready part in the picture A. This mock-up, no, of course, it's supposed to be stuffed with some separator. This separator, it means it's maybe some film, it's maybe some grease, in order the mixture of soil with binder do not adhere to this mock-up. Next, we do sand form, sand mold. How it's made? No, that you see in a picture B. No, it's just you see, just pour it. Some box, pour it with this mixture. Next, it's compressed, no, like close it tightly in some box. And here is you see already removing of this solid mock-up, and the mold, sand mold, it's ready to start rock. And next, how no, it's not sand. How it's work? We have already imagined. This casting process like this we may imagine. No, once again, it comes about complex shapes. That is why casting is what is valued for, let's say. But what if shape is not so primitive, like here, and what it's like developed in space, and this shape it can't be removed from this what sand mold, let's say, and it's not to be removed directly because no, it has some complex. No, like imagine the figure, the stature of man, sculpture, for instance, with hands. And quite clear if you try to repeat something like sculpture of man inside of this shape, quite clear you can't remove next this mock-up made of solid material, some ideal picture, no, not picture, but sculpture. You can't remove it without destroying the sand mold itself. And that was the reason for appearing of next type of casting. It's called investment casting. No, here is the scheme, and the scheme maybe it's little bit complicated. What is idea of this investment casting? The shape, this mock-up, this standard of part to be produced. The shape itself, it will be already not solid. It will be made of easy meltable material. Typically, it comes about wax, paraffin, something like this. Also, it may be some easy meltable material, no, for instance, plumbum, maybe. And first, we do their part of easy meltable material. In case it comes about manufacturing of hundreds of parts, we will see how to repeat it, let's say, hundreds of times. And in case it comes about unique parts, such a shape is made once. No, when it comes about casting, it's widely used in art also, by the way, in making of sculptures. When it comes about making the metal sculptures, you maybe understand that when it's casted metal sculpture, no any artist, no any sculpturer really made it first in metal. They do it in soil and or is some another easy meltable material. Maybe it's wax, as I'm already said, or some similar material, but no, synthetic one, some polymer. And next, what happened? Next, we do something like envelope in around surrounding this wax metal. No, let me to call it wax model. And this envelope infuser, it will be already the casting mold, casting form. What? No, it's complicated. Let's use this one. Investment casting, and here is also supposed to be No, that is the sand casting. That is not what we need. Not what we need. Not given here because I'm already do not remember clearly even my own notes. Так, investment casting. This one also too much complex as for me. Okay, they do something like wax pattern here, the same we see here. How to do the wax pattern itself, it doesn't matter. The part, final part, what it's shown at the place here, it's already in the process of measuring, of inspection, what parts looks like. What do you imagine that is the ready part, or at least ready cut, cast, and this wax model, some easy meltable model made of easy meltable material. First, it's produced by different means. In case it's individual manufacturing, if you need something once or maximum twice, it's maybe produced by hands, quite clear. In case it comes about the repeatability of this casts, about the thousand or tens of these casts. In this case, we have once again the sort of die of mold for making the mold, actually. Some shaping device is shown here, and the shaping device shape the wax model for you. Next, no, usually it comes about rather little elements, not big one. In case they are little, they are assembled into groups, something like preset. You see pattern assembly here, fundamentals, what they assemble them together. And next they are poured into something like liquid soil, for instance, or some another material which in liquid state, and after drying, it's solidified and create the shape. Again, it may be something sand-like. It may be liquid soil, for instance, after solidifying, after some polymer, some ceramics. It depends on what you're going to pour in. And this mold already, when this mold is completely dried, when it's already fixed, let's say, this mold is yet not ready to the work. Why? Because it's filled with these wax models that you have hidden inside. So mold is exist, but it's yet taken with some another material. But it's easy meltable material. And what is next? This form with wax models, wax pattern, it's placed to the furnace again. But not for drying. It's placed to the furnace in order to melt out material which is inside. And due to this, it's appeared a set of cavities after this material pour out of liquid, no, in the view of liquid. It's pour out of of the shape. You have the mold for pouring already with the metal that you like to have as final product. Such a complicated process, no, things like, but this process is also rather ancient, and it's what quite in such a way, without creating of these assemblies. It's used even in the most primitive manufacturing, like some tribes in Africa, for instance. They still do they traditionally do it, like some souvenirs, some little sculptures. Now they may send it to tourists, of course, but for instance, it was some objects of religious worshipping before, or they use it in some with some another purposes. It's one of the most ancient methods of casting, what in line with sand casting. Once again, sand casting mold is a period due to compressing some mixture of mixture of soil, sand, and binder, some adhesive material, and we just compressing this mixture with some solid mock-up of the trapetio part. No, and plus we leave some channels, some ducts for removing of unnecessary materials and for removing of excess of liquid material we are going to pour in. And investment casting, its use for making the mold itself, its use easy meltable material, its use practically it's soft mock-up, and this soft mock-up first is enveloped, it's due to the pouring into some another liquid, enveloped by the material that next it's dried, solidified, dried, and may be used as a mold itself. To remove this easy meltable material from mold, first we have step of heating up and pouring out of the easy meltable mock-ups, and next it will be poured with the material, with metal, for instance, with main material, which we mean to produce. And question is how to remove it. Of course, due to destroying of this form. So, however complex the form and however long we was to produce this mold, this shape, this form, it's one time easy destroyable form. What else? Like derivation, development of this process, what it may be. We have seen in classification, let me to show you once again classification here. What sound casting and investment casting. And somewhere it was gasificated casting, not here, no? What, evaporating casting. What? Look, sound casting and investment casting and evaporating casting. What is evaporating casting? Do pay attention, this is also categorized like temporary pattern casting. Why it's called temporary pattern casting? On example of investment casting, I hope it's completely clear for you already. What is evaporating casting? Evaporating casting, the only difference practically, what is with investment casting? The idea is completely the same. But when investment casting, it's made of material which after heating, no, pattern, this inner model, mock-up of part, it's made of is a multiple material. That one, it's made of material which gasificates, let's say, evaporates due to the heating. Usually it comes about some plastic. For instance, it's something like plastic foam. Let me to show you what do I mean, how I'm bored with this thing each time. Can't even explain you. What? Such material? No, it's called polymeric foam. I hope it's understandable for you once again to show you. No, this picture is visible for you. It's maybe of different appearance, of different dispersity, different no color whatsoever. You understand. If you try to heat it up, it's not even melted. It's not work as a liquid. It's immediately evaporates. It's like skip the stage of melting and it's gasificated. No, at least if we apply temperature high enough. And it just it's like disappear at all. And the only difference with investment casting, I said you that process is the same. The only difference is that in investment casting, what is called investment casting in English, it's poured out these inner patterns. And when it comes about this casting with gasification, actually the inner models, these inner patterns, they made of specific material, and this material just evaporate when you heating up the mold with these patterns inside. It's about, no, in this classification you see this expandable mold casting and it's temporary pattern casting. About this permanent pattern casting. Sand casting, plaster mold casting, it's practically the same, but material of mold is made not out of this sand mixture with, no, sand soil mixture with binder. It's just another type of material applied to do the mold itself. As I said you, how many different names you may meet when it comes about casting, not clearly visible, but to forgive me, visible. No? Another classification and dozens of different names. Again, another classification, some names and not quite the same classification. Not quite the same classification. Never be confused with those matters. If you understand what is the idea of process, no problem for you. But mostly all these processes, they are different by the way how to produce the mold itself. One more way, it's called shell molding. Here is what shell molding. What it's about? Very similar to sand casting. Maybe it's hidden in this classification with the name plaster mold casting. Mold may be made of glass. Sound weird, yes, agree. But again, it comes about one time usable mold. You understand it. It's so-called temporary mold. And this temporary mold, it will be with permanent pattern, permanent mock-up being used for constructing the mold. But mold will be usable only once. Likewise, the sand casting, likewise, the investment casting. To remove part, you need to destroy mold next. How? What does it mean? It's made of glass. No, you know, the glass, it's mixture of some materials, silicium, which actually is a sand. No? And in case you trying to heat up sand, it may be, no, especially in presence of some another chemical components like potash, for instance, it may be transformed into glass. And normally, instead of making just such sand mixture with binder that compress it, you may use some vessel, some let it be barrel with liquid glass, and you pour the permanent pattern inside of this liquid glass. Somehow it's similar to idea of investment casting, how to make a form. We just pour the pattern inside of this liquid glass, inside of this melted glass, waiting for solidification of this liquid glass around of pattern. Now question is how to remove the pattern. And glass, of course, it's extremely fragile, so it's necessary to be accurate. But glass form, it's cut along line or some lines. It's cut to the pieces in order to remove the inner pattern. In case this pattern was made of easy meltable material, in this case you may call it just investment casting. No, as it was made on solid material, it will be another name for this casting process. And this shell casting, as I already said you, usually it comes about something like glass practically. This shell will be separated onto a couple of pieces. Inner mock-up, inner mold, not mold, forgive me, inner pattern of fuse mold, of fuse cast. It's removed, and the mold, which consists now of two halves, it's assembled back. Of course, with leaving some hole, some opening for pouring the liquid metal inside next for making the part. But all the process of casting seems very similar to whatsoever sand casting, to investment casting, or this evaporating casting. It comes about only differences in making the mold itself. One more group. It's called die casting. Look at this. What here is. It's so-called permanent pattern and not expandable, not destroyable casting mold. What it comes about? Die casting. In our language, it has very weird name, kokil, such dies. Again, it's not our word. It's like come from another language to us. Die casting, it means that form for casting, it's made of metal this time. And its permanent mold will be, this permanent mold, it's for some dozens of times of using. During casting process, again, it's poured with liquid metal. You're waiting for solidification. Next, you remove it from this die mold, die shape. And that is usually used for melting. Quite clear that material this shape is made of, this mold is made of, it should be not meltable. It should be not meltable at the temperature that you use for material that is poured inside. So usually this die casting, which is very convenient, you don't need to produce these forms time by time, like hundreds of times to repeat it, like it was with expandable mold casting when you have patterns, and these patterns may be used to produce form which mold which you're going to use only once, and next it's destroyed after the casting process finishing. In this case, it seems like it's extremely convenient, but limitation is if you need to cast something made of material with higher point of melting, higher temperature of melting, no, it's not possible because you have no material for making the die itself. You understand, да? Even considering the rather short time of contact of material, of molded material and material of mold itself, anyway, it may be resulted in destroying of this permanent die for molding, for casting. And quite clear that die casting, it's used only for so-called easy meltable materials. It may be used for plastic and so on and so forth. What is next? Centrifugal casting. Centrifugal casting, as far as I remember, I have no such slide here. Yes, I haven't. Centrifugal casting we will see right now in a book. What is the problem of casting at all? That inside of molten metal you have some inclusions. Those inclusions may be of solid type and they may be of gaseous type. They may be some gases. And these inclusions, while solidification, they usually floating up. They strive, they trying to be removed. They trying to evacuate themselves from the mold that poured with liquid metal. Usually it comes about some another temperature, quite clear, of gasification than metal that poured inside. And that is why they start to move the first. And quite clear that they are trying to evacuate, to leave the mold, while another material after contact with the mold, with cold mold, it's already start solidified. And what is the problem? That this gas may not completely evacuate itself from the mold. It may stuck up, let's say, somewhere in the center. Plus to this, do remember what I said, that mold, as only it's contacted with the molten metal, make this metal to solidify because it's cold. And as only you reduce the temperature, wherever, of this molten metal that should be pour it inside and distribute it equally all over the mold. As only it has contact with surface of the mold, it start already solidifying. And problem is that it may create something like inner barriers, and it may make another metal to stack up again in the inside of the mold, and the mold will be not poured properly. It's like metal interrupt the process of pouring inside because it was too quickly solidified. In order to help material to be distributed equally and very quickly all over the surface of the mold, there are additional technological tricks, let's say, applied. One of the tricks is rotating of form, rotating of mold. Quite clear, it's work only for axisymmetrical shapes, like pipes, for instance, or do you imagine something like a bottle, for instance? In this case, it's work very well. And this rotation of mold is fulfilled by special machine. There are machines of centrifugal casting of different types, of different principles even. But idea is rotate the mold, quickly rotation of the mold. Immediately after, together with pouring with material, mold is rotated along the longitudinal axis, and due to this, centrifugal forces make material to move faster inside and to apply better to the surfaces of mold. And that is why it's poured, distributed inside equally, quickly, without inner barriers, without problems with filling the mold itself, and better surface quality may be achieved also. And quite clear, in this case, typically it's used because it comes about machine, and it's understandable. There is no time to restore these molds to machine. It doesn't comes about mold for one time of using. Usually it comes about metal molds also. So somehow it's remind the die casting, but it's for it's with additional, as I said, additional option, let's say, rotation of force. And it's usually used for axisymmetrical elements and usually used for rather big parts. Let's take a look here. Centrifugal casting. It's not. Here is maybe. Да? No. Cold chamber casting. Foundry practice. Oh, sorry. I'm not see here the centrifugal casting. I was quite sure that it's given here. Okay, next time I'll show you what it looks like. General idea you understood. It's called centrifugal casting, but centrifuge casting, but this picture does not explain anything practically for me. At least you see the part has axisymmetrical form. Here is this centrifugal casting. It's not about these machines that I talked to you about. It's not for pipes and so on. That is what in this example that we see seems like it's the same sand casting as you see, and same sand casting, but with rotating of the force of the form of the mold itself. It's also possible, you understand. And the surface finish quality, it depends in this case on depends on applying of the centrifugal force, of course, and also it depends significantly on material what may mold itself made of, material of mold. Of course, when it comes about metal molds made of metal, like die casting, like centrifugal machines, machines for centrifugal casting, the surface finish will be better. Surface finish, I mean parameters of surface roughness parameters of surface lay, they will be better than parameters of simple primitive sand casting. And one more casting, it's casting under the pressure. And how it's called in English classification, let's see, that one, it's called just pressure casting. What does it mean, pressure casting? It's usually it's applicable once again for easy meltable material like aluminum alloys. It's applicable for plastic, for resins, for whatsoever polymer-like materials. Actually, we are all surrounded with the results of this type of casting or these types of molding, if you'd like, because in English, I'm already said you, especially for this type of casting, they use this word molding. Plastic bottles, any pencils, not pencils, pens, the smartphone protective coatings, these additional devices to smartphone to protect it made of silicone. A lot of kitchenry that made of plastic. They are all made by this way of casting, pressure casting. Pressure casting, it means that you have some metal shape, metal mold. It's a permanent mold, which will be used in special machine. Quite clear, it's not already hand casting like it was in sand casting or investment casting. It's not like a craft process already. And this metal form, it will be stuffed not even with plastic in the view of liquid. Machine itself is downloaded with something like powder of low dispersity, let's say, in the view of of little particles. And this, forgive me, and this powder, which consists of those particles, in the dry way, downloaded into machine. And next machine function is to melt it quickly. Each cycle of machine work, it's melt quickly this granules, this compound, and it's like poured. It's not even poured, but it's like blasted inside the form. It's like shooting inside the form with this molten plastic or metal, which preliminary I said was downloaded into machine in the view of, let's say, big sand, big particles. And additionally, it's apply the force pressure inside of this permanent metal mold. Due to this material, it's like, as I already said you, as it shooted inside, really, and it's all enveloping the inner form of this permanent metal mold. What it's made for? How it was achieved making forgive me, another side of scrolling. How we make the inner cavity in case we use, for instance, sand casting process or some another process like this. Inside of ready mold, inside of ready shape for molding, for casting, it was inserted some solid element which prevent material to fill this area, and due to this, in ready part, it's appeared a hole. What is idea of pressure casting? Do imagine that you are blowing the air balloon, this children air balloon. And if you place some material into this, some half liquid material into this air balloon, in the beginning of this air balloon, when you blowing into air balloon, quite clear this material will be distributed equally to the surface. You try to use your imagination. And inside will be a very big inner cavity without any additional coarse, additional mechanical devices that prevent material to stack up inside the form. So this pressure casting, on one hand, it's necessary for it's used, it's maybe applied only for easy meltable materials, of course. But on other hand, it's applied for manufacturing of specific shapes, of envelope-like shapes, of thin shells, let it be. What in particular, it comes about plastic bottles, it comes about silicone parts of different kitchenery that girls use in kitchen, All this typically is produced by pressure casting. Once again, mold is permanent. It's used only in special machine, and in this case, it's applied air blast practically, air like shooting of material inside the this die cast, metal cast. Well, after what I said you about different processes, what we need to understand, the very first, that result of casting, in contrary to what we get used to think about, result of casting may be very different. It's maybe very rough cast after casting, in case you use primitive methods like sand casting, of rather primitive shape if we use sand casting. But on other hand, result of casting, it's maybe extremely delicate material, delicate thicknesses, good surface roughness, and so on. So casting that kinds of casting that appeared seems like differences between them only in different ways to produce the mold itself. Casting appears of results of casts, they appears of very different variety of quality inside of part, quality of surface, shapes itself, they may be extremely different. And typically, we get used to things that casting is rather rough process, which resulted in poor quality. Yes, typically, yes. And in aircraft manufacturing, casting is practically is not in used, especially for metals. It's not in used in manufacturing of parts of aircraft, but it's widely used for manufacturing of tooling, for manufacturing of parts, for manufacturing of tooling of secondary order, which necessary for assembly processes, and it's widely used as a principle. This principle of molding, of casting, it's widely used in manufacturing of aircraft for processes for manufacturing the tooling and for processes for coordination. No, I'm afraid you do not understand yet what does it mean, this processes of pre-production. You can't imagine it, maybe, what it comes about manufacturing of tooling, what sort of tooling and whatsoever. Next, it will be more understandable for you. But right now, we will stop on this, that casting is one of processes in the group, do forgive me, did I show you this? One of group of transformation of shape. Actually, what I wrote like one block, it's you have seen, depends on the author. It comes about 5-7 names, or the good couple of dozens of names of casting processes. Differences between them practically lie in differences of making the mold itself. The most of casting processes, no, in these classifications, they are for use, no, like they use the molds which are destroyable. They really for one time of using. To remove the part itself, to remove the cast from mold, it's necessary to destroy the mold. That is called expandable casting. Non-expandable or permanent mold, they are so-called die casting with additional force application, centrifugal casting with rotation of the form. And one more additional way to change casting process is to apply high pressure. It's applied high pressure and very quickly, and that is resulted in enveloping of poured metal over the surface of mold with appearing of huge inner cavities, let's say. That is the casting process. But in general, casting process is pouring the metal into some mold and solidification in this mold. That's it. Next group of processes will be the forging processes, maybe. But before we come up with forging processes, we will talk about primary deformation methods. No, right now I'm already again wrong with the time for one class because we have 2 hours. Let's stop.